In this video, we're breaking down the 4 pillars of IAM: users, groups, roles, and policies. By the end, you'll understand exactly when to use each one and how they work together to secure your AWS environment. And if you want to follow along in text format, check out the free study guide at preparato.com. Links in the description. So, what exactly is IAM? It stands for Identity and Access Management. It's the service that controls authentication, who can access your AWS account, and authorization, what they're allowed to do once they're in. Every API call, every console action, every CLI command goes through IAM first. It evaluates the request, checks the permissions, and either allows or denies it. Without proper IAM setup, you're either blocking legitimate access or exposing your account to unauthorized users. IAM is completely free to use. No charges for users, groups, roles, or policies. It's included with every AWS account and should be the first thing you configure before deploying any resources. One thing to remember right away: IAM is a global service. When you create a user or role, it's available across all AWS regions. No region selection needed. Before we dive into the components, let's talk about the single most important security concept you need to know: the principle of least privilege. This means you grant only the permissions required to perform a task. Nothing more, nothing less. Think of it like giving someone a key that only opens the one room they need access to, not the master key to the entire building. Exam tip: when you see a question asking about the most secure or best practice approach, least privilege is almost always part of the answer. Keep this in mind. Let's start with IAM users. An IAM user represents a person or an application that interacts with AWS. Each user has a unique identity within your account. Users can have 2 types of credentials. First, a console password for logging into the AWS Management Console through the web browser. Second, access keys for programmatic access through the CLI, SDKs, or direct API calls. Access keys come in pairs: an access key ID and a secret access key. And here's a number the exam loves to test. Each user can have a maximum of 2 access keys at any time. This allows you to rotate keys safely by creating a new one before deleting the old one. Here's something critical to understand. When you create a new IAM user, they have 0 permissions by default. They can log in, but they can't do anything until you explicitly grant them access. Every IAM user has an Amazon resource name or ARN that looks like this. You'll see this format throughout AWS. Managing permissions for individual users doesn't scale. That's where IAM groups come in. A group is simply a collection of IAM users. When you attach a policy to a group, all members of that group automatically inherit those permissions. Add a new developer to the developers group, and they instantly get the same access as everyone else on the team. Now here's an exam favorite: groups can only contain users. You cannot nest groups inside other groups. This comes up on the test, so remember it. One more limit to know: a single user can belong to a maximum of 10 groups. In practice, most users only need 2 or 3, but the exam might test this limit. Important distinction: groups don't have their own identity. You can't use a group as a principal in a resource-based policy. Groups are purely an organizational tool for managing user permissions. Now we get to IAM roles, and I cannot stress this enough. This is the most important IAM concept for the exam. If you only remember one thing from this video, make it roles. Unlike users, roles don't have permanent credentials. Instead, they provide temporary security credentials that automatically expire and rotate. This is a massive security advantage. Roles are designed to be assumed by trusted entities. When something assumes a role, AWS issues temporary credentials that last anywhere from 15 minutes to 12 hours. So, who can assume roles? IAM users in the same account or a different account. AWS services like EC2 or Lambda, external users through federation with SAML or OpenID Connect, and applications running outside of AWS. Every role has two key components. First, a trust policy that defines WHO can assume the role. Second, a permissions policy that defines what the role can do once assumed. Here's what a trust policy looks like. This one allows the EC2 service to assume this role. Let's look at the 4 most common role use cases you'll see on the exam. First, EC2 instance roles. When your application runs on EC2 and needs to access other AWS services like S3 or DynamoDB, you attach a role to the instance. No access keys needed. Second, cross-account access. When users in account B need to access resources in account A, you create a role in account A that account B users can assume. Third, federation. When you want employees with corporate Active Directory credentials to access AWS without creating IAM users for each person. Fourth, service-linked roles. These are predefined roles that AWS services use to perform actions on your behalf, like auto-scaling, managing EC2 instances. Exam tip. Whenever a question mentions an application on EC2 needing to access another AWS service, the answer is almost always an IAM role. Never access keys. Policies are where permissions actually get defined. They're JSON documents that specify what actions are allowed or denied on which resources. There are 5 types of policies you need to know. Identity-based policies attach to users, groups, or roles. They define what that identity can do. Resource-based policies attach directly to resources like S3 buckets or SQS queues. They define who can access that specific resource. Permissions boundaries set the maximum permissions a user or role can have. Even if you attach a full admin policy, the boundary limits what they can actually do. Service control policies, or SCPs, work at the AWS organizations level. They set guardrails for entire accounts. And session policies limit permissions during a specific assumed role session. Let's break down the structure of a policy document. Statement is an array containing one or more permission blocks. SID is an optional identifier for documentation purposes. Effect is either allow or deny. Action lists the specific API operations, like S3, get object. Resource specifies which resources using their ARNs. And condition adds optional requirements like source IP restrictions. Now here's where it gets critical for the exam. Policy evaluation logic. When AWS receives a request, it evaluates all applicable policies following this flow. Step 1. Everything starts with an implicit deny. By default, nothing is allowed. Step 2. AWS checks for any explicit deny. If any policy says deny, the request is denied. Period. Game over. Step 3. If there's no explicit deny, AWS looks for an explicit allow. If any policy grants permission, access is allowed. Step 4. If there's no explicit allow either, we fall back to the implicit deny. The golden rule. An explicit deny always beats an allow. If you have 10 policies saying allow and one saying deny, the deny wins. One more distinction. Managed policies versus inline policies. Managed policies are standalone. You can attach them to multiple users, groups, or roles. AWS provides pre-built managed policies, and you can create custom ones. They support versioning up to 5 versions. Inline policies are embedded directly into a single user, group, or role. They have a one-to-one relationship and are deleted when the identity is deleted. Best practice? Use managed policies. Only use inline policies when you need a strict one-to-one relationship that shouldn't be reused. Let's apply what we've learned with 3 scenarios you might see on the exam. Scenario 1. You have a team of 5 developers. They all need read-write access to a specific S3 bucket and read-only access to DynamoDB. Solution: create an IAM group called developers. Create a managed policy with the S3 and DynamoDB permissions. Attach that policy to the group, then add all 5 developers to the group. Why this approach? When a 6th developer joins, you just add them to the group. When the team needs access to a new resource, you update one policy. Clean and scalable. Scenario 2. An application running on EC2 needs to upload files to S3. Solution: create an IAM role with a trust policy allowing EC2 to assume it. Attach a policy granting S3 write permissions. Then attach that role to the EC2 instance using an instance profile. Why not access keys? With a role, credentials are automatically managed and rotated by AWS. No secrets stored on the instance. No risk of keys being committed to version control. This is always the right answer on the exam. Before we wrap up, let's cover 3 common pitfalls that cost people points on the exam and cause real security issues in production. Pitfall 1. Using the root account for daily tasks. The root account has unlimited access that cannot be restricted by IAM policies. There's no way to limit what root can do. Correct approach: lock away your root credentials. Enable MFA on the root account. Create IAM users for all daily operations. Only use root for account-level tasks like changing your support plan or closing the account. Pitfall 2. Embedding access keys in application code. This is a security nightmare. Keys end up in version control. They're visible to anyone with repo access. They don't expire. They're hard to rotate. Correct approach: use IAM roles for anything running in AWS. For external applications, use environment variables or AWS Secrets Manager. If you absolutely must use access keys, rotate them regularly. Pitfall 3. Using Action Star and Resource Star for convenience. This gives full access to everything. It violates least privilege. If these credentials are compromised, the attacker can do anything. Oh, guy. Correct approach: always specify exact actions needed. Limit resources to specific RNs. Add conditions to further restrict access. Let's recap the 4 pillars of IAM. Users represent people or applications with permanent credentials. Groups organize users and simplify permission management. Roles provide temporary credentials and are the preferred way for AWS services and cross-account access. Policies are JSON documents that define the actual permissions. In the next video, we'll dive into IAM best practices and security features like MFA, password policies, and credential reports. Now, if you're serious about passing the SAA-C03, we put together a completely free study guide at preporado.com. It covers all exam domains with diagrams, explanations, and the key points you need to memorize. Plus, when you're ready to test yourself, there are realistic practice exams that match the actual exam format. Trust me, practice tests are the fastest way to find your weak spots before the real thing. Link is in the description. If this helped you understand IAM, hit that like button and subscribe for more SAA-C03 exam prep content. Drop a comment if you have questions, and I'll see you in the next one.